Okay, let's begin the discussion of average atomic mass by filling out the table that you see here. In the first row, we have potassium, and potassium, if you look it up, has 19 protons. Since the atomic is 39, that must mean there are 20 neutrons, and since potassium is neutral, it must have 19 electrons to exactly balance the 19 protons. The element with the atomic number 53, that is with 53 protons, is iodine. And iodine then has 53 for its atomic number, which goes down here. And in fact, then the atomic mass, which is the sum of these two, is 127. So this is isotope 127 of iodine. And finally, we have iron. Iron's atomic number is 26. Which means that this isotope of iron has 30 neutrons for a total of 56. And now, since iron has a +3 charge, it has to have 26 protons. The way it gets a +3 charge is by losing 3 electrons. So in fact, instead of 26 electrons, iron has 23 electrons. All right, so let's talk a little bit about this atomic mass issue. Carbon-12 has 12 atomic mass units. In fact, the atomic mass unit that you see here is defined based on the mass of a carbon-12 nucleus. But in fact, carbon in the periodic table doesn't list its atomic mass as 12, but rather 12.01. Well, if the definition says that carbon-12 has a mass of exactly 12 AMU, how do you explain the fact that in the periodic table, carbon has a mass of 12.01? Well, it turns out that 93.98, almost 99% of carbon is in fact carbon-12. But about 1% is carbon-13. And that isotope then has 6 protons and 7 neutrons. And its mass is slightly over 13 atomic mass units. So the average atomic weight for carbon must be the percent for each abundance times the mass added up. So you might say, if you wanted to use mathematical symbols, the sum of the atomic mass, the mass of isotope I, times the abundance of isotope I. And if you add all of those up, this sigma means add them all together. Then you will get the average atomic mass. So here we have a situation where we have a mass of exactly 12.00 atomic mass units for 0.9893 98.93% of the atoms in any sample. But then you've also got 13.00335 AMU as the mass of 0.0103 abundance. And if you do that multiplication, you get 12.01 AMU, which is the mass that's reported in the table. So, in fact, the atomic masses in the table represent a weighted average of the masses of the isotopes that make up the element. Now, here's a way of looking at it in the other direction. So, copper has 2 naturally occurring isotopes, copper-63 and copper-65. 63 will have an atomic mass of about 63 AMU, and 65 has an atomic mass of 65 AMU. Copper itself has an average atomic mass of 63.5. So what that must mean is that 63.54 must be the mass of copper-63, which we'll call 63.0 AMU, times the abundance. Well, we don't know that, so we'll call it X. And then 65 AMU, the other 65.0, the other isotope, And we don't know its abundance either, but we can't use another variable because then we would have one equation in two unknowns. But what we do know is that the abundance of isotope 63 plus the abundance of isotope 65 must equal 1. So if the abundance of 63 is x, the abundance of 65 must be 1 minus x. Now, in a problem like this, one thing you should do before you actually carry out the math here is to realize that in a multiple choice problem like this, you can eliminate some of these answers without actually doing the math. Since the atomic mass is 63.5, which is closer to 63 than it is to 65, it must be that there's more of isotope 63 in the sample than there is isotope 65. After all, if the abundances were the same, then the atomic mass would be 64, the average of the two. So it must be that there's more 63 in the sample, and that accounts for the fact that the average is closer to 63 than it is to 65, which means that it's not 50-50. And it also means that it's not 25-63 and 75-65. It's either one of these, one or the other. Now, to solve this, what you need to do is combine terms. So what you're going to have is 63.54 equals 63.0x plus 65 minus 65x, leaving off the AMUs. Now, what you're going to want to do is rearrange this, and what we're going to do then is to bring the 65.0 and the 63 to the same side. So what you're going to have now is 65.0 minus 63.0 times x equals 65 minus 63.54. And if you do that math, what that's going to give you is that x equals 3%, which is 0.73 or 73%. So the correct answer is about 75-25.